Flashcard 26. State the law of sines. The law of sines. In any triangle, each side divided by the sine of its opposite angle gives the same value. To say it simply, the law of sines pairs each side with the angle across from it, and it's great to know when you know a side and its opposite angle. For example, the sides are represented by the small letters, while the angles are represented by the big letters. This means that the formula is small a over sine of big A equals small b over sine of big B equals small c over sine of big C. 3 problems to try. Number 1. We are given small a equals 10, big A equals 40, and big B equals 60. This means that small a equals 10 times sine of 60 over sine of 40. The answer is 13.5. Number 2. We are given small a equals 8, big A equals 30, and big B equals 90. We can find small b by doing 8 times sine of 90 over sine of 30, and we get 16. Problem 3. Pair sides with opposite angles. Small a over sine of big A equals small b over sine of big B. One tip is to pair each side with its opposite angle first. Now you'll need one complete pair to start. Background. This law works in every triangle, not just right ones, and the common ratio is actually the diameter of the triangle's circumscribed circle. This means the circle passing through all 3 corners. Beware of the ambiguous SSA case where the given data can fit into 2 different triangles. Flashcard 27. State the law of cosines for side C. The law of cosines. The law of cosines relates one side to the other 2 sides and their included angle in a triangle. Use this for SAS and SSS scenario triangles. To say it simply, the law of cosines is the Pythagorean theorem plus a fudge factor for when the angle isn't equal to 90 degrees. The formula is c squared equals a squared plus b squared minus 2ab cosine of c. You can see that the first half looks really similar to the Pythagorean theorem. 3 problems to try. Number 1. You're given small a equals 5, small b equals 7, big C equals 60. By using the formula, c squared equals 25 plus 49 minus 2 times 35 times 1/2. We get 39, which means that c is around 6.2. Problem 2. We are given small a equals 3, small b equals 4, big C equals 90 degrees. For this one, we can just use the original Pythagorean theorem since c is 90 degrees. So c squared equals 9 plus 16 minus 0, which is around 25, which means that c is 5. Problem 3. Small a equals 6, small b equals 8, and big C equals 120 degrees. Plug in all the values, and we get c squared equals 36 plus 64 minus 2 times 48 times negative 1/2. We get 148, so c is around 12.2. One memorization tip is that Pythagoras plus a correction term is essentially the law of cosines. The correction vanishes at 90 degrees. Background. Set c equal to 90 degrees and cosine of big C to 0, and the formula collapses to c squared equals a squared plus b squared. The law of cosines is the Pythagorean theorem generalized to every triangle, not just the right ones, with the last term correcting for the angle being more or less than 90 degrees. Flashcard 28. Area of a triangle given 2 sides and the included angle. Trig Area Formula. We can find the area by using half the product of 2 sides times the sine of the angle between them. To say it simply, to get a triangle's area without the height, use 1/2 times 2 sides times the sine of the angle between them. The formula would look like area equals 1/2 small a times small b times sine of big C. Here are 3 problems to try. Number 1. Small a equals 6, small b equals 8, big C equals 30 degrees. By plugging in the values, we get area equals 1/2 times 6 times 8 times sine of 30. We can simplify this down to 24 times 1/2, which is equal to 12. Number 2. We are given small a equals 5, small b equals 5, big C equals 60. The area is 1/2 times 25 times sine of 60, which simplifies to around 10.8. Number 3. Small a equals 10, small b equals 4, and big C equals 90. The area is 1/2 times 40 times 1, which is 20. One tip is to use this trig area formula when the height is missing. 2 sides hugging an angle is all you need for this. Background. This is the familiar 1/2 base times height with the height already computed for you. The altitude to side A has length B sine C. It lets you find area without ever locating the height, which is exactly what surveyors need in the field. Flashcard 29. Solve sine of theta equals 1/2 for 0 is less than or equal to theta is less than 360. Solving a trig equation. Find the reference angle, then place it in every quadrant where the function has the right sign. To say it simply, to solve a trig equation, find the reference angle for the size, then use ASTC, which is all students take calculus, to place it in the right quadrants. This means that quadrant 1, all the functions are positive, but in quadrant 2, only sine is positive, in quadrant 3, only tangent is positive, and in quadrant 4, cosine is positive. The formula is theta equals 30 and theta equals 180 minus 30, which is 150. 3 problems to try. Number 1. Sine of theta equals 1/2 on the interval 0, 360. The reference angle is 30 degrees since sine is positive in quadrants 1 and 2. So by using the formula, our answers are 30 and 150 degrees. Number 2. Cosine of theta equals negative 1/2. The reference angle is 60, and cosine is negative in quadrants 2 and 3. So the answers are 120 and 240 degrees. Problem 3. Tangent of theta equals 1. The reference is 45, and tangent is positive in quadrants 1 and quadrant 3. So the answers are 45 and 225 degrees. One tip to approach this is to first find the reference angle for the size, then ask which quadrants make the sign work. Background. Without a domain restriction, the equation has infinitely many solutions. Add 360 times n to each answer. Reference angle plus quadrant analysis is the universal recipe for every basic trig equation you will meet. Flashcard 30. State the even and odd identities for sine and cosine. Even and odd identities. Cosine is an even function, while sine is an odd function. Say it simply, even functions mirror across the y-axis, like cosine, while odd functions spin 180 degrees around the origin, like sine, as you can see in the graph. The formula for these functions is cosine of negative theta equals cosine of theta equals cosine of theta, but sine of negative theta equals negative sine of theta. 3 problems to try. Number 1. Cosine of negative 60 equals cosine of 60, since it's an even function. This equals 1/2. This function mirrors across the y-axis. Sine of negative 30. This equals negative sine of 30, since it's odd, so the answer is negative 1/2. You can see that the sign is flipped. Number 3. Tangent of negative 45. This equals negative tangent of 45, and the answer is negative 1, since it's an odd function. One tip for memorization is that even equals mirrors across the y-axis, like cosine, and odd equals spins 180 degrees around the origin, like sine. The background is that these identities are graph symmetry in equation form. The cosine curve is a mirror image across the y-axis, while the sine curve has point symmetry throughout the origin. They let you strip a negative out of any angle instantly.